The Big Bang. You know the story, right? It's pretty much the origin story for our universe, the one we all learn in school. But what if that story has a few, well, plot holes? Big ones. Today, we're going to dig into some really fundamental questions pulled from our source material that kind of challenge the whole idea at its very core.
Yeah, I know. It's a massive question. It almost sounds crazy to even ask it. But stick with me, because our source material lays out some pretty serious logical puzzles that are worth thinking about. So let's dive in and explore them. All right, so before we can really get into the critiques, we've got to do a super quick recap of the standard view. The official story of how everything supposedly began.
Okay, so this whole thing really kicked off back in the 20th century. Astronomers were looking up at the sky and they noticed something wild. All these distant galaxies, they're all rushing away from us. And get this, the farther away they are, the faster they're speeding off. This observation is like the absolute cornerstone of the whole expanding universe idea.
So, you see that everything's moving apart, right? The logical next step seems pretty simple. Just rewind the clock. If you play the movie of the universe in reverse, everything must get closer and closer and closer until, bam, you end up at a single, unbelievably dense point that just exploded. And that's it, the Big Bang. But here's the question. Is that leap in logic really as rock solid as we think it is? Okay, let's really get into it now, because this is where our source material throws up its first big red flag. It goes right after that first basic assumption, the leap from observation to conclusion.
Think about it. Does seeing everything moving apart really prove 100% that it all started from the exact same single point? Does it? Our source materials suggest that maybe that's a jump we make a little too quickly. Now, to make this idea a little less, cosmic, the source gives us a really simple analogy. So let's forget about galaxies for a minute. Just picture a train, a really fast one. Okay, so you've got two people on this super fast train. One of them starts walking away from the other. Now, if you're on the train with them, it just looks like they're slowly moving apart. But if you're standing on the ground watching this train whiz by, you see two people moving at an incredible speed who are also separating. The key thing is, the fact that they're moving apart from each other doesn't prove they both got on at the exact same station, right? So the source asks a great question. What if the galaxies are like those two people? What if they were already in motion before they started moving away from each other? All right, so that's the first puzzle, but let's move on to the second big question, and according to our source, this one might be an even bigger deal. This one isn't about where things started, it's about the very nature of the universe we see around us right now.
So just take a look at this. On one side, think about what an explosion is. Any explosion. It's just chaos, right? It's random debris flying everywhere in straight lines. Total mess. Now, look at the other side. Look at our universe. What do we see? We see unbelievable order. We see galaxies spinning in these beautiful, structured spirals. We see planets in stable, perfect, curved orbits. It's like the two pictures just don't add up at all. And this quote from the source really just nails it. It asks how fragments from an explosion, which should just fly apart forever, could somehow organize themselves into these complex, orbiting systems. Explosions break things and scatter them. They don't build intricate clockwork machines like a solar system. And this is the physics of it, right? An explosion is just outward force, push. Everything flies out in a straight line. But an orbit is this incredibly delicate dance between momentum, moving forward, and gravity pulling it in. So the question is, how on earth does a chaotic, violent explosion create that perfect, delicate balance? Not just for us, but for billions and billions of other solar systems. This, the source says, is a huge contradiction. Okay, so this brings us to our third and maybe the most mind-bending challenge of all. This one goes right back to before the beginning. This is a real head-scratcher. The standard theory says that before the Big Bang, there wasn't anything. No space, no matter, no energy. Just nothing. So if there was nothing, what exploded? You can't have an explosion if there's nothing to explode, can you? And once you ask that, a whole bunch of other questions pop up. Okay, let's say there was some original stuff there. Well, where did that come from? And what force possibly could have kicked everything off if nothing else existed to, do the kicking? It really boils down to a basic idea, cause and effect. Can you have the biggest effect in history with absolutely no cause?
All right, so let's start to pull all this together. As you can see, the source material we've been looking at isn't just nitpicking, it's raising some really serious, fundamental challenges to the whole theory. The whole critique really hits from three sides. First, the logic of going from expanding to single point. Second, the observation of order coming from chaos. And third, the causality problem of something coming from nothing. So, just to make sure we've got it, here are the three main takeaways. 1. Just because things are moving apart doesn't automatically prove they started at the same exact spot. 2. The universe is incredibly orderly, which seems to be the exact opposite of what you'd get from a chaotic explosion. And 3. The whole idea of everything coming from literally nothing is a massive logical puzzle. Now, to be clear, mainstream science definitely has its own explanations and answers for these puzzles. But the source material really wants to leave us with this final, thought-provoking question. It's a prompt for all of us to look at the evidence, to think about the logic, and to never stop asking those big, tough questions. Because really, isn't that what science is all about?